Okay guys, so here's a guide video. Um, Water is pumped into a tank at a rate modeled by this here, W of T equals that. So I'm going to identify right now that this is the rate in. So by this, liters per hour for time 0 to 8 hours. Okay, where T is measured in hours. Water is removed from the tank at a rate modeled by R of T liters per hour, where R is differentiable and decreasing on this interval. Selected values of R of T are shown in the table above. At time T equals 0, there are 50,000 liters of water in the tank. Okay, so this, guys, is the rate out. Now, something you want to be in the habit of is if they're telling you that something is differentiable on a free response problem, that is telling you two things. It's telling you smooth, this is how you spell smooth. It's telling you smooth and continuous. And continuous is very important if you're going to use a theorem, the intermediate value theorem or the mean value theorem or even the extreme value theorem. Those are our three theorems that we will often use. Well, not really the extreme value theorem in explanations, but the mean value theorem and the intermediate value theorem come up a lot in explanations. Okay, R is differentiable and decreasing on this interval. All right, so now if I let, okay, so I'm looking, I don't see A anywhere, like them using A. So at time T equals 0, there are 50,000 liters of water in the tank. So I'll just say A of 0 equals 50,000. A of T equals amount of water in the tank. So at some point in my work, I'll say let A of T equal the amount of water in the tank. So first, they want us to estimate R prime of 2, show the work that leads to your answer, and indicate units of measure. Okay, so for this one, guys, let me check and make sure I got it right real quick. I think I did. Yes, I got it right. Okay, so I'm going to say R prime of 2 is approximately. Now, if you're estimating from a table, and I know it's been a long year, but we did do this at one point. If I wanted to estimate like R prime of 1, I would do the average rate of change from 0 to 1. I would do the average rate of change from 1 to 3. And then I would take those two average rates of change and I would average them together. And that would give me a pretty good estimate at R prime of 1. Now, that's if you are estimating the derivative at like a given interior point on the table. Now, since 2 is between 1 and 3, we're just going to use the average rate of change from 1 to 3, and then right there, that's going to be our estimate, okay? Because 2 is not a value in the table, so we're just going to find the values that 2 is between and then do their average rate of change. So R prime of 2 is approximately R of 3 minus R of 1 over 3 minus 1. R of 3 is 950. 1190 all over 2. And then this is a calculator section. Type that in your calculator. Negative 120. And now R is in liters per hour. So this is liters per hour, but then per hour. And guys, especially those of you who are in physics, this is another way of saying liters per hour squared. So you could say that also. I'll say or. Okay. Now we'll do part B. Use a left Riemann sum with 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? Give a reason for your answer. Okay, and guys, when they're talking about like overestimates or underestimates, that is always going to have to do with sometimes concavity, but then if for a Riemann sum, if it's an overestimate or underestimate, that depends on whether the graph is increasing or decreasing. Okay, but for Riemann sums are rectangle sums. So we're going to have to ask ourselves if the graph is increasing or decreasing. And we'll draw a picture and then we'll see like whether it's an overestimate or underestimate. But for our explanation, we want to say use increasing or decreasing. So and guys, if you could visualize it, you don't need to draw a picture. But I'm going to draw a picture. And first I'm going to say, all right, so we want the total amount of water removed. All right, so I need to know that the amount out is equal to the integral of the rate out. Integral, I think there's a shadow. Integral of the rate out. And it's going to be from 0 to 8. And remember, a definite integral, that's the area under the curve. So I'm going to draw a picture. And the picture is optional if you already know what's going on. So I'm just going to like sketch these points. So we've got 1, 2, 3, 4, 5, 6, 7, 8. 1. All right, and then $13.40, $11.90, $9.50, $7.40, $700. Okay, at 0, that's the output. At 1, that's the output. At 3, that's the output. At 6, at 8. Okay. And I'm connecting these. Okay, now a left Riemann sum. The first subinterval is from 0 to 1. All right, so this is the base of the rectangle. Now, left Riemann sum means that for the height of the rectangle, you're using the left endpoint. So the left endpoint, so I go from here, and then I go up to the graph, and then I complete the rectangle. So right away, you can kind of see that we're going to have an overestimate. All right, now the second, so I'll have to do the area of that. Now the second rectangle, its base is on the subinterval 1 to 3, and then I go from the left endpoint, which is 1, up to the graph, and then I complete the rectangle. If it was a right Riemann sum, you'd be using the right endpoint and up to the graph. And then from 3 to 6, left endpoint, and then from 6 to 8, there's the base. All right, now for all of these areas of the rectangles, I'm going to do base times height. So base times height here. All right, and then base times height for the next one is 2380. Base times height for this one, base times height for that one. I already did it. Okay, so all right, so the integral from 0 to 8 r of t is approximately, and then you add all four of these up. $8,050 liters. Okay, so that's an estimate for the amount of water removed from the tank. Okay, now this is an overestimate. And it's an overestimate because, guys, they told us at the beginning, that's why they told us that R of T was decreasing. All right, so I'll say overestimate because R of T is decreasing. Okay, so there's part B. Part C. Use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of the 8 hours. Okay, so this is part C. And I'm going to say, let A of T equal the amount of water in the tank. And then I've got this antiderivative with an integral formula I can use. So A of T is equal to A of 0. It could actually be any number, you know, whatever number goes in here would be the bottom there. But there, I already know A of 0. A of 0 plus 0 to T. And then in here I go A prime. Now I'm going to mention this, I'm actually going to fix this later. Now we usually use W's, guys, because W is so rarely an input variable that the intention is to help us remember that this variable here needs to be different than that. But the problem we're about to run into is that they used W. And it's kind of hard to see the difference between uppercase and lowercase w, I guess. Maybe I'll just use both of them. I think I can do it. Yeah, I was actually going to change this W to an X because we're going to have to use this W. So you can do that if you want. But you know what? I'm just going to make my uppercase W look very clearly uppercase instead. All right, and now this here, guys, this A prime, let me just say to myself, A prime of T, this is going to be rate in minus rate out. The rate in was given as W. So this is going to be capital W of T minus the rate out is capital R of T. Okay, so this is what's going to be going in for A prime, and I've just got to switch the variable. So A of T, A of 0 is 50,000 plus the integral from 0 to T, capital W of W, and you could use X instead, guys. That might, maybe I should do that. It just, yeah, so I'm changing these to X's. It just can't be the same as that. You could choose any variable you want. Let me choose, W of W just looks weird. So W of X minus R of X dx. Okay. So A of 8, which is what we want, is 50,000 plus the integral from 0 to 8, W of X minus R of X dx. And guys, an integral like this, you can split it up, okay? Because we already know we're going to have to use math 9 for the integral of W of X, but they want us to use our estimate of the integral for R of X. So I'm going to split this up, 50,000. And guys, I'm showing a lot of work. And it's not actually necessary, all the work I'm showing. Okay, so just like this. All right, now this is approximately 50,000 plus the integral from 0 to 8 of w of x, we'll use math 9 for that, minus, now we already found that estimate, 8,050. 8,050. All right, now in a second, all right, so a of 8. In a second, I'll write that. Okay, so I'm going to do 50,000 plus math 9, 0 to 8, and then r of t, or w of t, is right there. 2,000 negative divided by 20 dx, and then you got to subtract. Oh wait, whoopsie, I messed this up. 80/50. Minus that. Okay, now how do they want me to round? To the nearest liter. To the nearest liter. So that's 49,786. 49,786 liters. Okay, now guys, as far as like what would be necessary to show, I would say like from here, like from here down, you know, above that is just me like doing instruction, like showing you where the stuff is coming from. Okay, now part D. Okay, this one is really hard. So part D. For t between 0 and 8. Let me focus. For t between 0 and 8, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? Explain why or why not. All right, so this is part D. So you want to be thinking, all right, so let's just think for a second. The rate at which water is being pumped into the tank is the same as the rate at which water is being removed from the tank. So is there a time when WT is equal to R of T? Okay. And guys, very often when you want to prove if two things are equal, you can prove that their difference is 0. So if you just subtract R of T from both sides, we want to see if this is true. Now guys, W of T minus R of T, that's actually, that's A prime, what I define to be A. Okay, so A prime. A prime of T equals 0. Okay, so guys, you know what we can do? We can make ourselves our own table. We can make ourselves our own table with W of T and R of T. Now, W of T, right here, that's a continuous, that function there, that is continuous on this closed interval. And then they told you that this was differentiable. So that means that this is also continuous on that closed interval. So if we want to prove that, so if these two functions are continuous and we subtract them, we'll just get another continuous function on the closed interval. If a function is continuous on a closed interval, then we could use the intermediate value theorem to show that it takes on a certain value, like over that interval. So I'm gonna do a little table here. So this is T, and then down here I'll do W of T minus R of T. All right, so 0, 1, 3, 6, and 8. Okay, guys, so go ahead of me, or if you want to give this a shot. Now, WT minus R of T. The R of T values I've already got right here. So I've just got to subtract them from my W of T values, which I will get from my calculator. And see, I already plugged W of T in there. And if you just, let me do zoom standard. I go like this. And I don't even see it. So I'll go to the table to try to get, let me go table set auto to try to get a feel. So, oh yeah, so at 0, the Y value is 2,000. Oh, and at 8, it's 81.524. So I'll go back to my window. I'll go to my window, 0 to 8. And then the Y mins, I'll do Y min 0, and then Y max, I don't know, I could do like 3,000. Let's just make sure it's continuous. Yep. All right, so we got a continuous decreasing function for W. Now I'm gonna do, let me go to this table. All right, now guys, I'm just gonna use the values in the table because they're not asking for these values as like part of the answer. So I just wanna get a feel of, so basically, if one of these outputs is positive and then another one of the outputs is negative, then I could use the intermediate value theorem to say, so there must be a value C between 0 and 8 for which W of T minus R of T is 0. Okay, because 0 would be between the positive and negative outputs. So, yeah, so I'll just go like this. So this is going to be 2,000 minus 1340. This is going to be 1902.5, so I'm just getting the values from here, minus 1190. And there are other ways of doing this, guys, shorter ways, but when I don't know if everyone will understand them. I think this is the easiest. With this, the way I'm showing the table, I mean, you got to use the intermediate value theorem, but I thought the way I'm showing this table would be the easiest way for everyone to understand. 330.6 minus 740. And then this one is 81.524. 81.524 minus 700. Okay. So 2,000 minus 1340. 660, 1902.5. 712.5. Okay, so I don't have a sign change. So if the value for which this is 0, I can't prove that it's between 0 and 1 because positive. So there's no sign change there. 1275.3 minus 950. Still no sign change here. 330. Right, there's a negative 409.4, and then this 481. Negative 280.47. Okay, so guys, I might as well just use the intermediate value theorem on this whole interval, 0 to 8, because look, there's a positive number, there's a negative number. So somewhere in between 0 and 8, there must be a value c for which this of c equals 0. Okay, because 0 is an intermediate value for these endpoints here. All right, so now I can do it. So I'll say this. I'll say since r of t is differentiable, it is continuous. W of t is also continuous on 0 to 8. So W of t minus R of t is continuous on 0 to 8. Okay. And then I'll bring in my values. So W of 0 is 660. W of 8, it's not equal to this, but. And 0 is an intermediate value. Therefore, by the IVT, there must be a number C between 1 and 8 for which W of C minus R of C equals 0. This means W of C equals R of C. So let's answer their question. So is there a time when the rate at which the water is being pumped into the tank is the same as the rate of the water being removed? So, okay, this means, therefore, yes, there is a time when, I'll just say W of C equals R of C. Okay, so the big thing here, guys, as long as you've got a valid explanation that uses the intermediate value theorem, then you've got it. Okay, yeah, what do they say? Their answer key says, their answer key says that you consider W of t minus R of t, and then you get the answer with an explanation. This is just 2 points right here. Okay, so, if you don't feel like it's worth your time, then, move on to something else if you're taking the test.